All right, so picking up where we left off, here's where we want to kind of gauge our progress. So if you think that the guided examples were enough for you to this point, then I would actually just be an advocate for just trying example 4 on your own. So pause the video and just go nuts and give it a shot. If not, then we'll walk you through it and we'll kind of take a look at some of the things we need to think about. So the big concern to this point is, how do I know if it's a disk method or a washer method problem? And the easy answer is you got to look at the region itself compared to the axis of revolution. So in this case, we're revolving a region around the x-axis. There's absolutely no space between the region and the axis itself. So what that tells me is that this is a disk method problem. Cylindrical disks are in play here. And so if that's the case, and in this problem it's not so bad because they did give us the limits of integration, I'm really ready to kind of go right into my volume setup, right? So pi on the outside, integrating from 0 to pi. And then, of course, we have the radius function, and that is squared, right? As usual, clean up before we get into this integration. In fact, this would be really difficult if I didn't do so. So we have sine of x dx. And now we're going to go ahead and begin the integrating, right? So the integral of sine is negative cosine of x. We're going to evaluate that from 0 to pi. Now what I like to do in a case like this is actually bring the negative out before I start evaluating. Cosine of pi is negative 1. Cosine of 0 is 1. So when all is said and done here, I'll end up with 2 pi. Right? Let's take a look at a little bit more of a complex situation. So if you turn to example 5, what you'll notice here is we have a slightly different situation. In this case, we are taking a region, and instead of revolving it around the x-axis, we are being asked to revolve it around a specific line, in this case y equals 1. So since we're revolving this around the line y equals 1, there is still no space. Now see, if we were revolving this region around the x-axis, there would be this vacant space between the region and the axis of revolution, and that would require a washer setup. But in this case, we are revolving it around the line y equals 1. So this revolution right here tells me, if you want to think about what does it look like symmetric, right? There's the bottom half of that. So you can start to see that if you take a better look at the three-dimensional pictures that I'm trying to show there. So we're taking, it almost looks like it forms a tire, but it's not because of the vacant space. It's really just because of where the region sits. But in a case like this, here's our issue. The biggest issue we have is how do we correctly, let's use the right term here, correctly identify the radius of this cylinder? Because if you think about it, the radius is from the center out, right? We're used to that being from the x-axis to the curve. And the x-axis, of course, has a value of 0. Well, that's not the case right here. Here the radius is from y equals 1 up to the curve. So the radius function, let's come over here, right, is the curve itself, 2 minus x squared, minus that line, right? Because if you think about it, if it was just the curve, then you'd have this distance from here down to the x-axis. Well, that's not the radius. That would actually more serve as the diameter of the cylinder. So we have to actually take away the line y equals 1. Now you'll notice in my notes, I say this integrand should look like k minus the function. So in this case, 1 minus 2 minus x squared. Here's why that actually doesn't matter. I like the way I'm writing it here better, but it doesn't matter because think about what we're doing. We are going to insert the radius squared into our volume setup. So if I'm writing 2 minus x squared quantity minus 1, and I'm squaring that, if I had to reverse that order, it wouldn't make a difference. So let's just get right into the setup itself, right? So volume is going to be equal pi from a to b. Now in this case, if I don't know what that is, I would have to set 2 minus x squared equal to 1. And when we go ahead and solve that, you will get x equals plus or minus 1. So those are my limits of integration. I have the radius function squared. So like we said, we have 2 minus x squared minus 1. All of that is squared. And of course, if you're going to go integrate that, you'd want to clean it up a little bit, right? So that's really 1 minus x squared, quantity squared. And then one more time I'd clean it up. And what does that give me? 1 minus 2x squared plus x to the 4th. So we're going to go ahead and integrate that. I'll let you go ahead and do the math, but I will tell you, spoiler alert, you should wind up with 16 pi over 15. Okay, one last one. I'm actually fast forwarding a little bit. I'm going to go look at example 7 because I want to skip to the washer method. And so the case here is we are taking this region bound by x minus 3 squared and x equals 5, and we are rotating that around the y-axis. So if we're going this way, think about the symmetry involved here, right? Here's the other side, and you can see in this picture, it almost looks like a laundry basket, I guess, with the bottom missing, right? So when we look at, okay, what should I make, what should I make my radius function? You have to get into the whole outer minus inner radius. So keep this in mind. This y-axis right here, that is your axis of revolution. So you have a function, you're going to always have a function here that is farther away from that axis of revolution. And for us, that would be the line x equals 5. And then you have a function that is closer, and that would be quantity x minus 3 squared. So that's one issue. Now, what's the second issue? Well, you asked me to revolve it around a vertical line, which means everything I do must be in terms of y, the variable y. So I'm obviously going to have to find some points of intersection, and if y equals x minus 3 squared and x equals 5, I can simply put a 5 in there, right? And that would help me out a little bit, and when I do that, I get 4. Now I can see from the picture, it goes from 0 to 4. But this is just something that that I may need to do by hand as well. So what does my volume look like? Well, still pi on the outside like usual. This time we are going from 0 to 4, right? Now remember, it's a washer problem. So the setup here is the outer radius squared minus the inner radius squared. And all in terms of y because it's a vertical axis of revolution. So we said before the outer radius was actually the line x equals 5. So there you go, 5 squared. And then we said the inner radius was this x minus 3 squared. But that's the problem. It's in terms of x. So what I need to do is I need to solve this guy. And I will wind up getting x equals the square root of y. And then plus 3 on the outside of that. So that winds up being my inner radius. And of course, all that is in terms of y. So this is a little tedious. And we talked about at length a couple times here, how do I clean this thing up? Well, think about what you'd have to do, right? So one of the things you'd have to do is make 5 squared 25. One of the things you'd have to do is expand this radical y plus 3. So you may even have to write that thing out twice. What you should get is you should get y plus 6 radical y plus 9. Then you might want to distribute and clean up and do all that kind of good stuff. Again, if you're not ready for the answer, don't look yet. But if you do everything out correctly, should wind up with 24 pi. Lots more to talk about in class. I'm sure we'll have some questions, so no worries.